Looks like it's about that time. Welcome back, everyone. So we're on week 4 finally, and the notable thing about week 4 is a week away from today, we'll be doing our very first exam. It can't be a very long exam since it's only a 50-minute class, so my exam has to reflect that. But it'll be in this classroom, it'll be 50 minutes in length, and the sample exam has been posted since last week. So if you have a chance, I'd say definitely take a look at those and get a feel for what the questions are going to look like roughly. But other questions at the moment, folks, before we start today? Okay, so our week is cut short by a day. I have a conflict with my night classes on Thursdays, or not on Thursdays, on this coming Thursday, but I don't expect any other exceptions throughout the rest of the semester. On Thursday, I'm still going to be on campus. I'll be holding office hours from 4 to 5 p.m. as I do on Tuesdays and Thursdays. So you're still welcome to come on by if you have questions. I'll be happy to help out. Also on Wednesday of this week, we're going to be reviewing for our first exam. Reviews weren't built into the schedule, but we're doing a 4-day-a-week class. We're actually about a day ahead, so I think a review day is definitely worth it. We have time for it in the schedule, so we'll go for it. It'll be kind of an impromptu review. So what I encourage the class to do is take a look at the sample exam 1 document or any interesting quiz problems or problems even out of WebAssign. And I'll be happy to take a look at any questions or problems that the class presents. If we are running out of questions, then we can go through this document here, just picking out a random question on a section by section basis and call that a review. But I think if it's student or directed, then that's probably better. So definitely, if you can find some questions to bring to the class for a review, that'd be very helpful for everyone. Well, that's my set of announcements so far. Any of questions at the moment? Okay, we have our 3rd quiz that's due today. I'll be posting our 4th quiz probably around Wednesday. Usually I'll be posting those a day early, and that I think makes really good sense this week in particular. Our section 3.4, we should get this finished off this week, but this one's a little bit longer. I think we'll finish off section 3.5 when we return after the first exam, which is about pace for our day-by-day syllabus. Well, that's our full set of announcements. What we're going to be doing in section 3.4, even though it's not on exam 1, it still kind of is a bit of a review of it because we will be talking about topics as we see them in 3.3. The major idea is we're taking those ideas of quartiles and medians, turning them into a 5-number summary and producing a box plot. And even better, we'll finally have a rule of thumb, at least, for determining whether an observation is an outlier or not. So we don't have to always just resort to visual inspection. So that's our goal for today in section 3.4. And here's how it looks out when we jump right in. So the list of formulas right before a problem is getting smaller in the reading, so that's always a good thing. There won't always be like a wall of text right before an example. And the first thing we want is the 5-number summary. That's what's building our box plot. And we've seen these quantities already. For example, the lower quartile, that one is Q1. The median, we write as M, it's MED in the calculator. Upper quartile is Q3. And the only thing that's really new here is the smallest observation. Well, that'll be the min, MIN for minimum. And the largest observation we'll put in for the max. So the 5-number summary is just a way to say, where is your data located? Where is it concentrated? And it's given values from lower to largest. Any questions at all, folks, with that 5-number summary there? Okay, from that, we'll build out a box plot. But this example 1's kind of just a warm-up example. We'll get our calculator going, crank out the summary, and see how this work falls out. First, we need to get through the context of the problem, just in case a question says, interpret values using the context. We're told that radioactive cesium, cesium-134, cesium-137, is a waste product of nuclear reactors. The reason that's relevant was there was a meltdown in 2011, and that's what this study is about. It says, a study examined the radioactive cesium tissue concentration of a random sample of 16 Pacific bluefin tuna, captured off the coast of California 4 months after the Fukushima nuclear reactor meltdown of 2011. So we had a really nasty earthquake. I think that one was magnitude 9 in 2011, knocked out a reactor, and just 4 months afterwards, they detected a spike in radioactivity in the tuna off California, clear over there. So that's what this whole study is about. Let me highlight to here, since that seems to be the main context, what the data is all about. It tells us next, here are the findings. The units are becquerels per kilogram of dry tissue. That's a very strange unit. And the kind of idea is that once they caught the fish to determine how radioactive it is, they pretty much just have to, I guess they ground it up and dried it out. And then they took a look at how much cesium was mixed into that particular fish after going through its remains, I suppose. So there's the data. We have 16 observations. So the sample size N is 16. And every one of these pieces of data have units of becquerels. I'll call it Beck for becquerels per kilogram of dry tissue. I'll just say becquerels per kilogram. So that's the unit on our data here. We have numeric continuous data. And our goal is to analyze it further to see what we can determine. So any questions so far, folks? Okay, so that's our study. Here's all the data. And the data was thrown into a histogram right away, which is nice. It's always good to see what the shape of the data is before you go to work with it. If you saw these data, there's possibly different kind of answers folks might have. How about for symmetry? Would you all call it symmetric, or would you say it's skewed in a direction? How about roughly symmetric on this? Would you all say that qualifies? Okay, one good rule of thumb with this is if you stare at something, you can't just say immediately skew to the left or slightly skew to the left versus the right. If it's kind of even hard to tell, you definitely have some symmetry going there. So I'll say that these, even though it's not a question, I had to double check, it's roughly symmetric. How about for modes? Would you call this unimodal, bimodal, or worse? I agree with this one. Usually we've been looking at unimodal data, right? But in this situation, this histogram was built in a way to show where the data is really concentrating. These kinds of formulas are trying to show that there is really a peak here and really a peak here. So we're looking at bimodal data coming from this distribution. So let's say here, bimodal. Let me change the colors. Blue might have a meaning in a moment. So two peaks, well, we have bimodal data. I would say there's no apparent outliers just based off what we see on the histogram, but that's already kind of a unique feature with these real world data that we are dealing with here. Now to go to say, historically, the mean radioactive cesium tissue concentration in bluefin tuna has been below 2 becquerels per kilogram. So if you saw these data, that's concerning, right? Everything is well above the 2 becquerels per kilogram. And some of these fish are very radioactive. I don't know if these will glow in the dark or not, but I'm not a nuclear scientist, but it seems like it's way up there based off the 2 units down below here. So our goal now, after looking at this, absorbing the context, is this tough question right here. Describe the population and the sample. Any volunteers for one or the other?
Population be like all bluefin tuna in the sample, be the radioactive tuna in the sample?
Exactly. We would say for the population, all bluefin tuna. And if this was an answer, I would say I would give full credit to this. I'm going to add a little bit more because what makes this kind of a tricky problem is populations, they don't just change geographically, they also change with time. And after this event right here, the bluefin tuna became a whole new population of fish after all that radioactive cesium was dumped into the ocean. So if you want to be really specific on this, you could say all bluefin tuna caught, or excuse me, let's not say caught, that's the sample, all bluefin tuna near the coast of California 4 months after the meltdown. So that's the population we were really interested in. What does that population look like 4 months right after? So that'll be our population. I forgot to say population. Let me put that here. And then as what you said as well, these fish that we caught, it came from this population and those were just the ones that they caught. So we can say very briefly, the sample is the 16 tuna selected. Now, our hope of hopes is somehow, some way, this was a random sample that could take a lot of work to justify and a lot of work to really build and enact. We'll have to trust the experts, the biologists, that these are typical fish from the population of all the bluefin tuna. But we've got it, folks. That's what our population is. Here they're saying the population's average has historically been less than 2, but now our sample's average is way bigger. We have evidence that the population really did indeed change after the meltdown in 2011. Well, any questions, folks, with population and sample on this one? Okay, with what I wrote in black, that's what I would say qualifies for a good full credit answer. What's in orange right here, that's just adding a little bit more of the context. If it was an exam setting, you don't want to write too much on any one problem, but it's good to keep these in mind because it might bear into some of the other questions. So let's take a look at part B. It says calculate the 5-number summary for these data and round values to 2 decimal places if necessary. So now we're throwing everything into a calculator and visualizing these data. I think this is the last part of that question. It was a pretty quick problem. So this is our opportunity to practice putting this all into the calculator. And keep in mind on exam 1, pretty much what we're about to do right here is the main takeaway you should be ready to go for operating your calculator in an exam setting. So once this is on, let me go back to the stat key to start out. Hit enter right away and just start dumping in all that data. So let me up arrow and clear it out. And I'll go row wise. I'll try to be silent so I'm not disrupting you as you type. Okay, looks like folks are just about there. Let me give everyone just a moment. Okay, if we're happy with our data, just hit the stat key one more time, right arrow, and enter like 4 or 5 times. It's like 4 times on my calculator here. And there's our data. Again, this is always kind of tricky in a way. Some problems are going to ask for the sample mean, that's our X bar. Some want the standard deviation, that's SX. What this question is asking for is none of that. It wants the 5-number summary. Anyone recall the trick in the calculator to get there? Exactly, just keep down arrowing and you get all of the other output. So that's the screen you need to be on right here. Let me take a quick screenshot. Preferably one without the red dot. It just looks kind of weird to leave in there. So we have it, folks. That's our 5-number summary. That's a weird way to leave it on the notes since that would look unnatural for sure. So let me just write this extra bit. The minimum is 16, quartile 1. Is 8. Our book calls this the lower quartile, but we've been using Q1 since it matches up a little bit better with what's in the calculator. Then the median value, M, comes out as 10.5. Quartile 3 is 11.8. And finally, the max value came out at 15.6. So we did it, folks. That's our 5-number summary. And that's where this question ends right here. Yeah, go ahead.
For minimum.
Oh, thanks for spotting that. I think I looked at the sample size N and grabbed just the wrong number there. So this ought to be a 4.6. Thanks for spotting that. Now we've got a better 5-number summary. Other questions or comments at the moment? Okay, well, that promise is once you have this, let me put just a fast forwarder here to say we did it. That's the end of part B. But once you have that, you can now construct the box plot. Let's do it right here and now, just for the sake of extra practice constructing these kinds of things. And this is something we might have to do by hand on, say, exam number 2, coming up in a while. So let me just hide this formula for the moment. Now let's give this a try. The box plot, it starts off with just a long horizontal bar, kind of like your dot plot. But keep in mind, it's all about presentation. So some of them you'll see in our book go horizontally like I'm about to draw. Some of them go vertically, but it's just a matter of a stylistic choice. They're all considered the same type of plot. For the paper here, or my Microsoft Word here, just a little bit easier to go horizontally, so I'll go this route. We want to capture all the data between 4.6 and 15.6. So let's go with, say, a 0 here. Step unit of 5 might be just fine. So 0, 5, 10, 15, and 20 captures everything. That's good because these data are a little bit confusing. It's how radioactive your tuna are. It's a good idea to put something here on the horizontal scale. This is becquerels per kilogram. Recall that was the unit of how radioactive our particular fish was that was caught. So this is now finally the trick when it comes to a box plot. First thing you'd want to do is put down the actual box of the box plot. And that comes from quartile 1, quartile 3. So to the best of your ability, place a vertical bar right where Q1 is. That's at 8, so I'll put it about here. Just like with the dot plot, we don't put it on the actual x-axis. We want it to float above to be away from the axis. And that's helpful if there's more box plots we're comparing, for example. Next one we'll put is at 11.8. So that's just going to be about here, right around where 12 would be. Once you have your quartiles, you can fill in the box. So the color coding is telling us where everything is going. And our kind of goal here is to go from the 5-number summary to the box plot and be able to reverse it at the same time. Once you see a box plot, you should know where the quartiles are, the median, the minimum, and the maximum. So we have a box. Definitely we're doing a box plot. Inside that box is the median. Now the median's tricky because it is possible for your median to be exactly equal to quartile 1 or quartile 3. If that ever happens, there's just like another vertical line here. It's maybe extra bold to say things are overlapping. But for us, it came out at 10.5, so it's about right here. And that's a perfectly straight line. So that's where the median is. And so at a glance, you'll know exactly that the 50th percentile is right about here at 10.5. So that's the inner core of the box. Now with the minimum and the maximum, we draw out what we like to call whiskers for no apparent reason. Some people call this a box and whisker display, if you've heard it called that. So that's for the whisker, 4.6, goes right about here, just to the left of 5. It comes in as just a skinnier vertical line segment. That now signifies the minimum. A bar goes over, and it stops like that. Next, we do the same thing for the maximum. That's at 15.6, so it goes a little bit further to the right. Maybe about there. Now, you don't have to have a ruler. They don't have to be placed perfectly. As long as the whisker is in the right neighborhood, say not way out here beyond 20 or way over here close to quartile 3. If it's right around here, then that's always going to be considered full credit. So we've done it, folks. That's our complete box display for this graph. Any questions at all on producing it? Okay, it tells us quite a lot. Let's also remind us features of this. From here to here is 25% of observations. The reason that is right here, that's where quartile 1 is. If quartile 1 is the 25th percentile, 25% of the data should be to the left of it, from here to here. Inside of this, that's 50% of all the observations. let's call this something a little bit more fancy because it is kind of a fancier region right here. Let's call this the central 50% of observations. So by that, we mean just the middle 50% of the entire group goes in that location. The distance from here to here is the interquartile range, but the central 50% goes from that location to that location in your data set. Likewise, here to here, that's 25% of observations as well. And these particular data, they turned out not to have an outlier. But if our data set does have outliers, we have to include them in this display as well. That's what we're going to be studying a little bit next. So think of this as kind of a preview to our box plot. The other box plots will add just a little bit more to detect if they're outliers and how to signify them to alert the reader. But that's the idea of the box plot. The main goal of a display like this is just to see at a glance where all the data lies. We have a strong concentration in the middle, 50%. 25% is spread out that way, and 25% spread out that way as well. Well, any questions or comments, folks, on this display? Okay, well, let's try it out to the longer problem then next, one where we will have to use our 1.5 times the interquartile range rule of thumb. This thing right here. In statistics, one thing you always want to be a little bit careful of is anything that's called a rule of thumb. That's indicated as a rule of thumb on purpose. The reason for that is your author's trying to alert you that if you go into a specific discipline, maybe you're doing statistics in engineering or psychology, or maybe pharmacology, the rules of thumbs change. The way that people decide something is an outlier or not is sometimes discipline specific. If we want to give someone just a way to determine if they're outliers, this is a starting point, but it's not the end all be all of what absolutely makes an outlier or not. A lot of judgment still goes into it, even after you've used a rule of thumb or not. But here's how it goes. An observation will be considered an outlier by this rule of thumb if it exceeds the upper quartile plus 1.5, 1.5 times as much, the interquartile range. Or if it's less than the lower quartile, minus 1.5 times the interquartile range. That's a lot to absorb. So my major goal with example 2 is really to work with this, break it down and see what goes where and how to check if there are outliers or not. This data set will have outliers on one end, but not on the other. So now with that rule of thumb there, let's take a look at our new context and we'll construct the box plot from scratch afterwards. So these data are kind of silly, but it is real world data. What happened here is the Cornell Lab of Ornithology, so bird studies, holds an annual Christmas bird count. And you could check that out right now on birdsource.org if you're really curious, in which bird watchers at various locations around the country see how many different species of birds they can spot. So this is how you can imagine it. You're just doing a Christmas party for these people associated with Cornell Lab. And during that Christmas party, as birds fly by, you're just counting the different species. So let me highlight right here. Sorry, say again?
I just said it must have been a boring party.
It must have been, but you know, if they are doing a Christmas party, I bet you alcohol was involved. So who knows how wild it got. In particular, some of these, like this one, so they, in one party, claimed they spotted 184 different bird species. That's pretty amazing. It might be true, but I would find that kind of suspicious. Most people are around, say, around 80 to 100 different bird species. Again, that's not really my idea of a party, but if you're into bird studies, that's probably just really, really fun way to have Christmas, I guess. But there's our data, and what we'll do with it is construct a box plot. So that will give us an idea of where are all these data really falling? Where are they concentrating? Are there outliers, or is there skewness apparent in this data set? Any questions, folks, before we begin? Okay, well, they told us there was 20, so it's not a bad idea to just start by saying n equals 20. On a real exam, I'm probably going to keep my data a lot less than this. If there is a problem that had 20 observations, meaning the rest of the exam has to be shorter for that little extra time to import the data. And let me see if I can find a way to put this in here. There we go, that just sort of fits. So let's go back to stat, back to edit, and same kind of deal. This is always a good trick though, especially since the last problem had 21 observations, and today on this one we have 20. Always go up. So L1's highlighted, hit clear, and enter, and then you're starting fresh with no hidden data somewhere in that list. All right, let me put it in. I'll be quiet while we enter data. Oh dear. Notice I didn't have my screen showing these two observations here. My data is going to look a little bit weird. Let me know if I get the right numbers when I hit the calculate button. I have a suspicion I might have messed it up. All right, I definitely have 20 pieces of data. Now, just like before, hit stat, right arrow, and enter. So I got my sample mean as 117.15. Is that checking out for folks? Awesome. Typically, if our means match up, we'll probably have the right data. And if we really want to be sure to match up the standard deviation or something, that'd be extremely good evidence. We definitely had the right data put in. So finally, here's my output. And let's write this out as a sequence of steps. If you're going to construct a box plot, what we just did is really step one. In step one, we need the 5-number summary. So let's just start writing it in. The minimum is going to be 82. It always looks weird when you see that X there, but just completely ignore it and you have the right value of 82. Quartile 1 is 97.5. Our medium value M is 112 bird species. Quartile 3, I'm definitely going to need some space. Let me just put some in there. 132 bird species, and the maximum was 184. Okay, let me go back to the document here. So we did it, folks. That's step one. If you want a box plot, you definitely have to have this. Now this takes us to our step two. And step two, essentially what we're going to do is look at this rule of thumb again. Our objective is, before we start constructing the box plot, we really need to know if there are outliers or not, because that will affect how the plot looks. So let me put this down below. And here's our next step we need to work on. In step two, if we're going to use this rule of thumb, notice it involves the interquartile range used twice. So first thing I need to do is pick up interquartile range. Let's call it IQR, our typical acronym. I mean, that's a one thing the calculator doesn't produce for us, but it's not so bad. You just go to quartile 3 and subtract from it quartile 1. So that'll be 132 minus 97.5. And that's got to be something like 100 or 34.5. Yeah, something like that. So 34.5 species is the interquartile range. So that's just the distance from where the central 50 are contained. It has that length. So step two is done. And so far, it's really not too bad. Here's step three, finally. And step three, we're going to run through the formula because now we have the interquartile range. We just need to pull out quartile 3, quartile 1, and compare it against the data that we have. We really want to do this kind of in stages. So I'm going to start with the first part. I'll take the upper quartile, that'll be Q3 at 1.5 IQR. So Q3 plus 1.5 multiplying interquartile range at this stage, this is more of an algebra problem. We've seen this a little bit before. We're just making loads of substitutions. From Q3, look up 132, that goes in the first spot. I'll keep in black the things I'm not substituting, so copy plus 1.5. And next is interquartile range. So another lookup on step 2. I'll use parentheses to indicate multiplication and go parentheses 34.5. Now we just want to jam that into a calculator and see what result we get. So 132 plus 1.5, 34.5. These calculators are nice in that what you see right here, you could just type in verbatim, parentheses and all. Parentheses will still indicate multiplication in the calculator if written this way. So our whole value comes out to 183.75 bird species. Now, once we run through the formula here, we need to read the whole rule of thumb once again. It said an observation is an outlier if it is greater than quartile 3 plus 1.5 times interquartile range. So anything larger than that value is an outlier in our data set. Anyone see what the outlier would be, or if there's none on the upper end?
184 is, but just
Exactly. Anything exceeds is our outlier. So this one definitely did exceed this value right here. And we can say next, let me get some extra space. Since 184 is greater than, the greater than coming from that statement there, 183.75, 184 is a suspected outlier. Now, notice the wording here is kind of strange. I'm going to say suspected or potential outlier. The reason I'm saying that is this is just a rule of thumb. It doesn't say for sure with absolute certainty one way or another whether it is an outlier. What it means is this is a place to start. Things that are flagged as an outlier by the rule of thumb, they're just suspected to be one, and now you have to do further investigation. So if you were in charge of this crazy Christmas party, you probably would go to the people with the 184, take a look at their pictures, and maybe they did have a little too much scotch or something, and there's 30 birds of the same species. Maybe that happened, and maybe it's not even an outlier, but it could be real. It could just be an unusual spot they happen to be in. So we'll say here, 184 is a suspected outlier. So suspected coming from the fact it's just a rule of thumb. You don't have to say potential outlier or suspected outlier, but that's a good thought to always keep in mind. None of this is saying for certain one way or another. Well, we do have a suspected outlier, and when we go to the box plot, we'll put a little open circle to signify it, to alert the reader of that plot, there will be an outlier. But now the thing that's annoying about this rule of thumb is you have to run it twice. This is just the upper end that we check. Now we go and look at the lower end. And notice the difference in the formula here. If you're checking the upper end, you're looking for anything greater than, which means there's going to be a plus right here, and there should be the upper quartile Q3. If you're looking for the lower boundary, it should say less than. You should have the lower quartile because you're looking on the lower end. And there should be a minus as well. So that's how the formula changes. Really, it's a small change, Q3 to Q1, plus to minus. So let's try it again. Take Q3, excuse me, I already made a mistake. Let me try again. Take Q1, the lower quartile, subtract from it 1.5, multiplying the interquartile range, IQR, Then make some substitutions. Everything's been calculated. Q1, we can look up and find a 97.5. Then subtract 1.5 multiplying. IQR we used once, it's 34.5. And now we just have to crank out that computation there. So back to the calculator. I'll just retype the whole thing as 97.5. The minus right here is the only thing that will work. Avoid that negative sign unless you're importing data and it happens to be negative. Then 1.5 times 34.5. So lower quartile, we've got a 45.75 bird species. Now let's reread the rule of thumb again. It says an observation is an outlier if it is less than this quantity we just calculated, 45.75. But if we look at the data, in fact, we don't necessarily even have to look at the data. We look at the minimum is at 82. Nothing is below 45.75. The smallest one was about 82. So the 5-number summary can be a really rough check, or just look at all your data. Here, all we have to say is, since no observation is smaller than, or less than, I'll go with smaller than, 45.75, there are no outliers on the lower end. So we did it, folks. That's the conclusion of step 3. Now, with all that information, we're ready to do the whole box plot. Just a lot of little things to get out of the way before we even begin on that. Any questions at all, folks, on running through either of those steps? Okay, I'll call this step 4, but this is the main thing that we wanted, the full and official box plot. I think we should be able to fit this in. So in step 4, the main thing we have to worry about is that one outlier. But first, let's set our scale. We have a minimum going from 82, going all the way to 184. So we could go, say, up by 20s. Maybe you might try 25s. And that should do the job. So I'll go from, say, 80 to start. I'll go by 20s. That's just slightly easier arithmetic for a start of 80. So 100, 120, 140, 160, 180, and it ends at 200. This scale would be number of bird species. So with that set, same thing as before, go first to your 5-number summary. We're going to build the inner box, but before we put in the whiskers, we'll use this observation here, 184, as a suspected outlier. But in fact, let me highlight it in yellow so I don't forget about it. So we have something at 97.5 on this scale, right about here. So here's my first portion of the box. Something at 132, so right about here. That closes off our box, so we finally have a box in our box plot. Next thing, throw in the median, which is at 112. That's going to be really close to this very far left quartile. So that means we're definitely looking at skewed data already just by this much of the box plot. Looks like the data is skewed far to the right this time because there's a lot of concentration right here in this end. Now let's go. We said there was no observation smaller than 45.75, so no outliers at the lower end. That means for the lower end, it's just business as normal. Your whisker is at 82, so draw a line that goes about like this, slightly to the right of 80, and that's the extent of the data going off to the left. Now, about that outlier, it's going to cause problems with our graph because the whisker here no longer goes to 184. What we want to do is make a box plot that shows the main extent of the data and anything additional like the outliers not connected to it. So first we put down 184 here as a solid dot. So there's our outlier. I'll highlight this in yellow just to say it came from right here. In fact, let me just extend this highlighting. That's our suspected outlier right in that region. But now when we go to our data, let's scroll just a touch above. We're not plotting that anymore. It's taken care of. It's still our maximum, but now what we need to plot for our whisker is this one, the value that's not an outlier. If 166 was an outlier, my whisker would not go to that one. It would go to 150 instead. So for this problem, our whisker goes all the way over to here, 166. Maybe about in that location. I was going by 20, so maybe just slightly further to the right to make it look a little bit better. To my eye, that's my best of my ability. 166 has got to be about there. 170 is in that location. So that's our whole display. So this time, the 166 went down to here. And that's how we have to plot our box plot whenever there are outliers. Well, we did it, folks. That's the full construction. It definitely is a lot of steps. So when you see this on, say, exam 2, that's one that's going to take just a little bit longer to get through. Other questions at the moment? Okay, well, now that we have the box plot, let me copy this portion right here. Oh, I must have typed 10 for no apparent reason. Here's the context of these data. Rule of thumb was just for easy reference. It's still above. Now, this is what we would like to do next. Right here, where it's scrolled to, this could be a problem in its own right on, say, exam 2, where all you have is the box plot. It's been fully constructed. And now what you must do is describe what you see using the context. Whenever you see something that says using the context, that can be a challenge in these kinds of problems. It means you have to be talking about the bird species in this Christmas party. Something from the original problem has to be here. We can't just say the data is concentrated around 110. We have to give it even more. And this problem wants at least 3 items. So let's give this a try. It didn't say which items. So anything that you can see that's interesting on this display that you would like to mention, if it's correct, it would automatically get full credit for this kind of question. Well, any volunteers for the first thing that's kind of noteworthy when you see that display? Absolutely. I'd say this is a very, very skewed kind of picture. So if you see skewing or other oddities, we ought to mention it. So we can say, these observations for number of bird species is right skewed. So I said number of bird species, and that means, yes, we are bringing in the context that would qualify. If we are told that something is right skewed, that means the lower end values are more typical. Around here is what we expect, that there is a few rogue Christmas parties that had huge, huge results. And that's absolutely what we're seeing in this display. So already saying right skewed colors the kind of data we're getting out of this. Any volunteers for a second thing to mention? Absolutely. If you ever see an outlier, I think that's the easy one, right? The outliers are the low-hanging fruit. Mention that, and you've got one thing immediately. Outliers are always weird. They always deserve mention. And these particular data, let's say here, there is an outlier of, now, if all I had was a graph, I'd just say of about 182 or something like that. If I had the actual data, I would use 184. But we've done this before. You could just say there's an outlier in the upper end. That's okay too. You wouldn't have to say the specific value. So depending on how the problem comes in, as long as you mention it where it is, I'm always going to be happy with that. In fact, let's do that on this problem. It could have been a problem where you never even saw these data, it's emphasized by deleting it. And you could just say, there's an outlier of, I was going to say, on the upper end. So when you change the sentence, there's an outlier for bird species on the upper end. Well, that's two things down. One last thing, and we're done with the bird species. Any last volunteers for the next thing to mention? Here would be my go-to. Every time I see a box plot, this would be the thing that I would always want to mention. So if you had to say three different things, I mean, that's one thing off the list. Definitely outlier is a good one. Definitely mentioning the skew is another good one. But what's interesting also about a box plot is it tells you where the central 50% of all of your observations lie. And that's pretty good information too. So we can say about half of all the birdwatch locations found between, on the lower, if we were just looking at the plot, I would say 95 to, if we're looking at, say, the upper end, I'd probably say that it looks like a about 130 species. Again, on this problem, if you went to just look up the quartiles, 97.5 to 132, that would make this much more accurate. About half, you may not have to say. But if you're only looking at the plot, giving me an interpretation, that would absolutely qualify as well. You don't have to mention specific values. There could have been other things that you might have suggested. Some people might have said, it's interesting that the median itself is right here. That's where data concentrates, not the central 50. That's where all the data concentrates. That's the 50th percentile. Other people might have mentioned that the 25th percentile is at, say, around 85 species. That's pretty interesting as well. It would alert the reader that not too many people, well, about a quarter of the study was below that value there. So you should expect typical values to be larger than the lower quartile. But there's lots of things you can say. There's no one more correct response necessarily for that kind of question. Really, the goal of the question is to know if you understand how to read the plot and tie the context in at the same time. Well, other questions, folks, with getting through this one? Okay, well, box plots are an adventure. One thing that we've only hinted on here and there is the skewing of them. Skewing in box plots are tricky. So when we come back, we'll draw a few more just to get a feel for what do the shapes look like if we're just dealing with a box plot and not even a histogram. I think for us, we shouldn't try a problem in 2 minutes. Probably a good stopping point. Any questions at all, folks, before we call it a day? Okay, well, have a great night, everyone. When we come back, we'll finish off these notes, and then we'll start section 3.5 on Tuesday. If you've got your quiz, don't forget to send them in. And if you're emailing them, no worries. Okay, question? Sure.
What observations here? I know you mentioned that are concentrating at 112 species, is that right? Because that would be the median.
Yeah, exactly. So that's where the most typical value be found.
So that's not the 50th percentile.
The median would be the 50th percentile. Yeah. And pretty much everything that's kind of curious about that box plot sort of comes from here as well. You have 50% in there. But you would also have 25% going from here to here, 25% going there to there. So you can mention all sorts of interesting regions on your display.
Perfect, thank you.
Yep, you bet. Any questions?
No, I just-
Awesome, thanks. Yeah, absolutely. That'd be perfect.
I have a question relating to the testing earlier. You sent me an email, but I didn't quite understand it, so I was hoping you would clear that up for me.
Absolutely. So you mentioned you want to take the exam on the test day, but just earlier because of a conflict, right?
Yes, I also apparently just found out I have a time conflict on Thursday and Friday and the
Oh,
weekend.
geez. that's
I
great.
know, I'm
We'll take
like,
care of them one at a time.
I'm trying.
Yeah. Well, for the Monday exam, pretty much what we can do is I could have that exam set to the testing center on this campus. And so you would just take it earlier in the day.
On Monday?
Yeah.
No,
Monday was, you want it earlier in the week or?
maybe this week or later next week. That's what I'm hoping. I guess I
Gotcha.
can't do it early Monday and I can't
Mhm.
do it late Thursday.
Gotcha. Well, what I can do is take another look at my schedule and email you back. Will that work for you?
Okay, I'm
Gotcha.
trying, I'm sorry.
No, you're just fine. No worries. And I think I'm trying on your name.
It's
Eileen?
still spelled it wrong.
Oh, no, I'll get there. You might,
Yeah, don't worry. I'm very used to people spelling my name like that.
yeah. There's gotta be a lot of different spellings for the same pronunciation, I'm thinking.
Yeah.
Okay, I'll email you and we'll go from there. You bet. Awesome, thank you.
Okay, am I rounding wrong? Because I'm doing all the right steps in the calculator. I would think I'm just rounding wrong.
So let's see. Do you have your calculator with you today?
No.
Let's try it up on maybe. We got this one right here.
Oh, okay.
How about this one?
It's like I can pull it out. Maybe.
So what were they asking? They want mean, standard deviation?
It's probably something that you like.
Yeah, there's a weird
really better
way.
than
You
I
could
am.
go to an app store and get emulators and you can flash your ROM on your computer with a USB cord and then like,
Like, I got that exact same like emulator, I just don't
You
have
do?
like the file for it.
I do have some ROMs if you need them. You can email them to me.
Yeah.
Email me and I can send you a ROM.
I have
if you
an
like.
even better answer, if you just happen to have it, like.
I do happen to have it right here. Do you got a thumb drive?
Yes, sir.
I have an 84 and an 83 ROM.
First to the 84.
Okay.
Can I just leave my stuff at home with you guys for a second? I really have to pee. I'm sorry.
Which must be school drive. Yes. There you go.
Thanks, sir.
You bet. And so on
I just got that.
this one, let me clear this out. Okay, so it goes 44. 49.6, 62.2, 28.2, 39.4, 39.8, 60.5.
Sorry to
72.
take the free time. I didn't-
Oh, no worries. I think we've got time. Same 3.0. 5, 56.5, 65, 6.1, 57.8, 73.5. Oh, that'd be a problem. 66.2.
That's just a long time still.
4. Okay, I think I've got it in.
Okay.
So 19 observations and they said, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 14, 15. 1, 2, 3, 4, 5,
I
6.
just entered it into.
I got 18, 19. Okay. So you said, I was just double checking, I got the right number. That's my biggest mistake is I like skip a
Yeah.
value. And this is what I got for the output on that. We have 51.32, and if I rounded this to 4 decimal
Okay, yeah.
places,
So I
that
got
must
the
have been it.
286, that's the issue.
Yeah, it's gonna be 51.3167, something like that.
Oh, so I'm just rounding.
Yeah, they want to go up to the 4th place is the issue.
Okay.
They're real jerk about that.
And then, oh wait, not 3. So then that one would be 15.9.
Yeah, exactly.
And then, is this not, am I not putting the same thing for the?
It'd be the same value, yeah.
Oh, okay.
So it's probably just the rounding still.
Okay, that's all I need to know. Thank you.
Yeah, you bet.
Are you doing anything in printing class tomorrow?
Tomorrow we
Always in
finish, yeah, I agree. Yeah, we're going to be finishing 3-4, starting 3-5. But our review for exam 1 is really gonna start on Wednesday. So as far as exam goes, nothing major tomorrow.
I don't want it tomorrow Wednesday, it's my birthday, but I will. Okay, thank you so much.
Yep, you bet.
Oh, and then we don't have Thursday.
We do have flat Thursday, you're right.
Anyway, so.
Yeah.
it worked out.
Hey, free day for us. Oh, gotcha. Sure. Let me just get this.
Completely missed this earlier. But I don't know how to do 18.
Sketch a graph of a function for which. Oh, so when it says f of 0 is 0. That would mean. Oops,
It's straight now.
yeah, that'll work. It's got to do something like that. At the x coordinate of 0.
Okay.
So we have a horizontal tangent line to match that slope. Oh, f of 0 is 0. F
Yeah.
prime, oh, that, let me try again. F of 0 is 0, so there's that one point. And the derivative at 0 is 3, so the slope is 3. So I have to go right 1, up 1, 2, 3. So the next point should be about like that. So I have to come through and go up steeply like that to get the slope 3.
Okay.
Then the derivative at 1 is 0. So when I go to 1, it should have leveled off more like that to get that tangent line. Then the derivative at 2 is -1. So when we go to 2, it should be decreasing at a slope of a roughly -1.
Wait, so how is it f prime 0 at 1?
The F, this one
Yeah.
here, the f prime of 0, it should have a slope of 3 is what it's saying. And so for this to have a slope of 3, we'd sketch out a tangent line. Slope 3 is because it goes right 1, up 3.
Okay.
Does that make sense for that tangent line there?
No, it doesn't.
Let's see. So if the f prime of 0 is 3. Grab some other paper here. So your question's mainly about that one,
Yeah.
right? So what I would do here is if it says f prime of 0 is 3, they're really talking about a slope relative to when x equals 0.
Yeah.
So if we go to a graph, I'm going to first do the tangent line.
Okay.
The tangent line has to have a slope 3, so I'll go right 1, up 3 to make that happen. So there's the m equals 3 for the tangent line.
Okay.
And now when I go through, it's got to really look like a tangent line. So it should look something like that, right around here. Does that make sense on getting that portion there?
Kind of.
Gotcha. So the idea is you have to draw the curve. It should be going up because the slope is positive.
How
And it
important
should-
is this to know?
I would say it's good, it's important enough to know how to sketch,
Okay.
but the exact details of that to that, not as important. That makes sense for that one?
Sure.
Gotcha. Oh, we've got just a couple more minutes before we start. We'll turn that in. Yep, thanks. Well, welcome back, folks. Let me get this classroom back in order. We have the lights on. Well, it looks like it's time to start. Welcome back, folks. So there's no seating arrangement or seating chart here, but the only requirement is to have a 1 seat separation from your neighbor, just to give some elbow room. Aside from that, I'm not too worried where people sit next to. Also, keep in mind, you're welcome to have a calculator. The allowable models are anything like this, like the TI-30XA, those typical testing calculators. The graphing calculators aren't banned on the actual exam, so if you have something like this, you're in good shape. And if your calculator breaks or if you forgot one, I do have a couple spares that you're welcome to have. Just let me know when I come by. Let's see here, about 7 o'clock, class has started. Welcome back, everyone. Aside from that, you are welcome to have a page of notes for your calculator, any writing utensils you might need. I put in lots of white space on this exam, so you shouldn't need scratch paper, but if you think you might, on the very last page of this exam, it's really blank space, a trig table. I'll put the trig table on all the exams just in case there's some trig we have to get through. You can freely tear this off if you like and use it as scratch, but if you don't think you need to, you don't have to. If you have lined scratchbook paper, that's okay too. Well, I think that's my spiel. Any questions before we get started, folks? Okay, it's a 60-minute exam, but we're going to call time officially at 8:15, since that I kind of think makes more sense than 8:07. Let me know if that just feels weird to you, and we can change it for the next one. Well, I'll pass out the exams. This is all we're doing today, so when you're done, you're welcome to leave. But I encourage you to use the extent of the exam time to just double check your work, since these things get tricky for sure. Once you get your exam, you're welcome to begin. And I intend to have these graded and returned back to you on Wednesday's class. Yeah, that will do that.